We previously introduced the concepts of reliability and validity. We talked about validity. Let's take a look at reliability, or consistency of measurement. There are various types of reliability. Stability reliability simply reflects that you get consistent results across time.
Equivalent reliability would mean that you take Form A and Form B of an exam, and do you get the same score from both instruments?
For example, you might have taken the SAT, and when you took the SAT, you took Form A, and the person sitting next to you took Form B. It shouldn't make a difference which test you took. There should be consistency across the test.
Another measure of reliability is internal consistency. This has to do with looking internally in a measuring instrument and seeing that all of the items that are used in the assessment are contributing to the overall scale.
Objectivity is a special case of measurement reliability. Essentially, objectivity is inter-rater reliability. You often see examples when judges at Olympic events are shown to not intercorrelate very well. That is, judges from one country rate a different country differentially than other judges might. That's an issue of objectivity or inter-rater reliability. You see it in diving, gymnastics, and dancing events where you have to have judges rate performance.
How do we actually assess measurement reliability? Well, we have to have more than one value. Most of the time we have two values, but sometimes we may have more than two values measuring the same concept.
How can you determine consistency if you don't have it at least twice?
So the procedure is going to be to use some correlational technique. The most common technique is a simple correlation between two values. If I step on a scale and see what I weigh, step off and step back on the scale, I would expect to see the same value again. So if we correlate several trials of stepping on the scale, the correlation should be very high.
There are some problems with that correlational procedure, which we'll talk about later on, but essentially it's looking at how consistently are you measured from one time to the next time. That's what reliability is all about.
Sometimes we have more than two trials. In that case, the correlational technique is something we'll discuss in a later chapter called interclass correlation.
What's the relationship between reliability and validity? Remember, reliability is consistency of measurement, validity is truthfulness of measurement.
A measurement must be reliable before it can also be valid. So if it is valid, then it must be reliable. However, a measurement can be reliable but not valid. If a measurement is consistent but it isn't measuring the concept that you think it's measuring, we have the problem of reliability but not validity.
This figure summarizes the relationship between reliability and validity. Notice that reliability is on the horizontal axis and validity is on the vertical axis. Reliability can range from 0 to 1, and validity can range from 0 to the absolute value of 1. Look at the yellow square. It's desirable to have high reliability and high validity. It's undesirable to have low reliability and low validity. It's possible, in the green box, to have high reliability, but low or poor validity. And it's impossible to have low reliability and high validity. The reliability and validity of your X and Y variables are important when you're conducting statistical analyses.